Hello everyone. For this week's discussion, the exam 4 review, I chose to do number 13, which says, identify the chapter or chapters in the textbook that cover this hypothesis test. And the test is the chi-squared test of independence. So the chapter in this book that covers this is chapter 22, section 4, which starts on page 624 and goes through page 632. For my example, I am using the problem on page 624, table 22.5, which says, generally, is the risk of hepatitis C related to whether people have tattoos and to where they got them? So, for my assumptions and conditions for this, first of all, we need counts and enough data so that the expected values are at least 5 in each cell, which every one of these is a cell. Also, the data need to be representative and a random sample from a population, which in this case, our sample is 626 Texas patients who are being treated for non-blood related diseases. And also, the sample needs to be fewer than 10% of the whole population. So moving on, the null hypothesis for this problem states that tattoo status and hepatitis status are independent, where the alternative hypothesis says tattoo status and hepatitis status are not independent. So this is the table that's on page 624. It gives you the number of people who have hepatitis C and who don't have hepatitis C, and if they have a tattoo from a parlor, if they have a tattoo from somewhere else, or if they don't have tattoos, and then it totals all the numbers up. So for a chi-squared test of independence, we want to find the expected values of each cell. So for this down here, to find the expected values, I did the math real quick. I just copied the numbers from the books, but then I double-checked them to make sure they were correct because one of the numbers has a misprint. So I rounded the expected values to 2 decimal points, whereas the book has 3. So if you do that rounding, you'll get slightly different results, but not enough to make a huge difference. So for the expected values in each cell, we take the total of that row divided by the actual total, of all these added together. So we get 52 out of 626 equals 8.3%, and then we take that number times the column totals to get the expected values for each cell. And I wrote them in right there. The first number is the observed, and the second is the expected. So you go through all that. The only problem I found with this is that 2 of the cells violate the expected cell frequency, which is the condition up here that says the counts and data need to have expected values of at least 5, but down here we get 3.90 and 4.58. But since they're close to 5, we can continue with the test. So coming over to this page, this is the formula for the chi-squared test of independence. So you take the observed minus the expected, which in this case, up here, come back here, the observed is 17, and the expected is 3.90, and then you take that divided by the expected, which is also 3.90. You do that for each cell, and you add them all together, and right here we get 57.91 for our test statistic. So then you go to the table and try to find that test statistic, but obviously it's very big, so we're not going to find it. So our p-value is less than 0.0001, which obviously is very small. So if you come down here to our data visualization, we have 2 degrees of freedom in this test, so that's why the graph looks like this, a curve downward. Our test statistic is 57.90, which is way out here compared to the rest of these. So obviously it's, again, very, very small. And due to how small our p-value is, we can reject our null hypothesis and conclude that hepatitis status is not independent of test 2 status. However, since we did have these two numbers that violate the expected cell frequency condition, we would need to check that they didn't influence the result too greatly. But otherwise, yes, that is a chi-squared test of independence, and I found that on page 624 and 625. Thank you.